So, hello everybody. Thank you for coming. Good morning, or good whatever time it is in your time zone. This is Especial and Fortuna Scale. What have we learned? And it's going to be me presenting, and there's also John here, which is my colleague and friend, and is going to be supporting and jumping in when there's some information to add. So a little bit of backstory for this talk first. So first of all, if you don't know who I am, my name is Vittorio Romeo. I work at Bloomberg, and in 2016, I joined the company as a software engineer. And in that year, I mainly worked in infrastructure teams, dealing with trading systems and micro messaging services and stuff like that. And as you can see here in the picture, that's our building in London, and that's where I'm based, in the London HQ. During those years, I've been in training, and I've noticed that CS+11 was becoming more widespread inside the company, including 14, but there really wasn't any real internal training course that helped people go up to speed with the material. So I basically just stepped in and I was like, let's try it out. I designed a few short courses that I gave as part of my to my training class, and people really enjoyed them. And that's kind of how I got started into professionally teaching as part of my job. 2018, I was C++ now in Aspen. Good times when you could travel and actually see people face to face and shake their hands. And I was with John. We were doing some gym workouts, enjoying the conference, and it was pretty nice. And we came up with this idea to basically, since it has been a long time since 11 and 14 were released, why not take a look at the impact that they had on a large corporation and try to analyze the features and what they provided to the language from the lens of a large company. So something like, we know that how this feature works, we know what you can do with it, but what does it mean for a large company? What does it mean in practice? What are the real use cases? What are the real pitfalls that you might find if you are teaching this to thousands of engineers? So this was our plan to basically co-author a book, which is called Embracing Modern C++ Safely. And in 2018, I remember that we said, this is a book that writes itself, which, I wish we never said that. It's been a long time writing it, and we really learned a lot. And this is why I felt like between 2018 and 2021, that we were like kind of rediscovering C++ 11 and 14 as a whole. We've done a lot of research work. We have had communication with ISO committee members. We've been at ISO meetings ourselves. And, we talked to the people that originally wrote some of the feature proposals and things like that. And it was a really, interesting time, because even though you might think 11 and 14, and they are quite old nowadays, we discovered a lot of things that were not obvious, and also got some nice information in terms of background and backstory of why some features were added and what their intended purpose was. So it was quite an interesting rediscovery time. And finally, it's 2021, and this is the year our book will be released in Q2. Again, the name is Embracing Modern C++ Safely. It's a bit of a tongue-in-cheek name. That's safely there. Well, I'm going to explain it later, but basically, what we're trying to do is basically provide a mostly objective look at features from the point of view of a large company, but also try to categorize them and tell people, these are the things that you should probably teach to your employees, and these are the things that probably teach only to your experts and things like that. We're going to dive into the meaning of safety a bit later. And John is known for having his book, a bit delayed, but hopefully this one will not be the same, and is going to be right on time, and you'll be able to enjoy it in Q2. So what are we going to talk about in this presentation? The first question I want to answer is, why are we still talking about 11 and 14 2020? I gave you a little bit of sneak peek at the beginning, but I think that it's a very valid question. And 11 and 14 can still surprise you today. I'm going to show you some examples of that. And then we're going to talk a little bit about the problem of 11 and 14 at scale. So what does it mean to use these standards at a very large corporation? And then we're going to analyze the meaning of the safety of a feature, which I think is an interesting concept that can help you understand where we're coming from. And finally, we're going to have a case study of one of the features that we deem unsafe in the book, extended threat declarations, and we're going to show you, what they are, how they work, why we think they are unsafe, but also what kind of real use cases they have in practice. Okay, so these are some results from annual survey that ISO CPP does publicly online, and basically they ask developers a lot of questions regarding C++. It's just a way of getting information. And one of the questions they ask every year is, what is the adoption of new standards like in your company or in your, for yourself? And in 2018, these were the results. And as you can see, C++ 17 was just starting to get a bit adopted, but 11 and 14 were still not fully adopted, even in 2018. We have a percentage of around 83% for 11 and 58% for 14. So you can see even in 18, we were just lagging behind with these standards. Fortunately, in 19, we had a bit of progress. 11 and 14 were getting closer to 100%, but still, as you can see here, 14 is just 65%, which is not great. And then in 2020, which was last year, we had almost a full 11 adoption, so that's pretty nice to see, but still C++ 14 was lagging a bit behind. So what I'm trying to show you here is that the results might seem good at a first glance, but if you think about it, even in 2018, about 20% of the people were not fully using C++ 11, which means most of them were probably not using it at all, or some of them were using it in a limited fashion, which is, avoiding some features because of compatibility or policies in the companies and things like that. And in 2020, so, just last year, 25% of the people that were in the surveys were not fully using C++ 14, which is a bit scary. It's been 6 years already, and people are still not fully adopting the standard. Sample size is obviously something that we need to talk about. It was around 3,000 people in 2018, then 2,000, then 1,000. So unfortunately, the trend here is that people are getting less interested in answering these surveys, which is quite unfortunate because it's just once a year. So take this as a call to action for next year, and we can get some better data. And also, my personal experience tells me that C++ 11 is still a kind of a luxury in some places. So for example, there are places where there are legacy architectures that do not really support modern compilers. Bloomberg is one of them. Fortunately, we have been moving away from these legacy architectures, but we do have some machines that run important code for the company. And these machines have architectures which just do not support compilers that allow 11 and 14. So that's something to take into account. And the other thing is that I tend to stay pretty active in the community. I like being on the C++ subreddit, some C++ discords and Slacks, things like that. And I still see people complaining nowadays about not being able to use 11 or 14 or 17. Maybe it's a vocal minority, maybe it's just the people that are unhappy that are speaking out. But the truth is that even today in 2021, some people don't have the luxury of using 11, and some people have just started using it. So it's a bit unfortunate, but that's the reality of the matter. And it's still a new thing, even though it shouldn't. So I don't know if Zoom allows us to do this, but what I would do right now is just get a show of hands. Is there anybody in the audience that is not able to use 11 or 14? Maybe the track host will help us if we can do some sort of short show of hands. Okay, so I already see some messages in the chat. Yeah, still nowadays some people can probably not use it. Some people only 11. So I do see some issues here. Okay, so why are we talking about this stuff? Well, because eventually, hopefully, you'll be able to use it, and it would be nice to have those 10 years of experience fully equipped with 11 and 14, but when you start using it after it has been out for 10 years, you would expect that you have the right knowledge and information to use it effectively. So that's what we're trying to solve, right? We're trying to get all the experience that we have so far and help people that are just adopting it or will adopt it soon to do the right things. And experience matters. I don't want to sound cliche, but experience is always the best teacher. I've been using more C++ since 2012, so slightly a year after 11 was released. And that's how I fell in love with C++. Fortunately, I didn't really, live in the dark ages of C++ 3. I was able to use lambdas and auto and all this good stuff right from the beginning. I've been doing hobby game development and video courses and stuff like that, and I've had a lot of experience with it. Also, in some companies like Bloomberg was a pioneer for C++ 11 and 14. We have people like Alistair Meredith and other people that participate actively in the committee, which have been shaping 11 and 14. But again, due to legacy architectures and issues with the build systems and things like that, it is only becoming more widely used in production over the past 6 years. So it's not like in 2011, everybody was using 11. It was a very slow burn, but nowadays, pretty much everybody has some exposure to it. And also been teaching it professionally for like 4 years now, both inside the company and outside the company with some, video courses and stuff like that I've done for some services. And I think, experience matters a lot. And I want to make sure that all that experience that I have and other people like John have is communicated in an effective way to people that need it. I want to say there are very good learning resources already. Like there's the books, for example, from Scott Myers, which are excellent. But something that I've seen in those kind of resources that they kind of teach you the features rather than the experience. And what I mean by that is that the information contained there is super valuable, is super nice, but you see it from the perspective of somebody analyzing the feature, not what has been done in practice with that feature and what were the problems that were found in practice with that feature. And sometimes what looks good on paper, you can look at this feature and be like, oh, this is amazing. It can solve all my issues. But then in the real world, when you start adding in, engineering teams, when you start adding in people, then you might find out that maybe it's not something that you should teach everybody. Maybe it's something that you should just limit to experts, or maybe something that people just, confuses a team of people. Maybe a single individual can understand a feature really well, but when you start sharing that feature with other people, it becomes a little bit problematic. Okay, so by the way, I didn't mention this, but feel free to stop me at any time for questions. I think we have a Q&A feature in Zoom. You can use that or even the chat. Or, if you want to speak out, also just let me know and we can unmute and talk. I'm really happy to keep this interactive. So how can 11 and 14 surprise you today? So there are many ways of doing that, and I think that many features can be unpredictable, even if you're experienced with the standards. But I want to try this experiment, and I want to ask you, the audience, what is the smallest change to the core language that you can think of in C++ 11? The most innocent, smallest core language change that you can think of. Let's see if anybody guesses. Oh my God, that was so quick. Yeah, Chris, exactly. We're on the same page. This is what I was talking about. It's the change that they made to the parsing logic to allow you to close nested template types without having to put a space between the closing angle brackets. So if you didn't have the pleasure of working with C++ 3, you should know in C++ 3 when you had multiple templates like a vector of a map of something, you were required to put a space between the closing angle brackets. Otherwise, the compiler would be forced to recognize that token as a shift operator. Pretty annoying. But yeah, it looks very innocent. So they just made it so that you don't have to put a space there, so that now it's consistent with the rest of parentheses and braces and whatever. But even that small change, it can make a valid C++ 3 program ill-formed, or it can silently change a program's behavior. So these are things that are unexpected. Like, how can this small change do that? And these are not things you would encounter in practice, right? It's very rare that something like this would actually break a program. But I think it's a nice example because even something as innocent as that can actually result in a silent change in behavior. And that's what we love about C++, right? Pretty much everything can have a pitfall and something to be worried about. So I'm not going to spend much time on this, but just to pique your curiosity. This is an example of what is valid in C++ 3. In C++ 3, you can say something like added buffer of this division done by right shifting. This would be fine, but in C++ 11, now the parser thinks that this is the end of the template. So in C++ 11, this would be ill-formed, and you would have to put parentheses around the expression. So very basic example, not a big deal, but I think it's interesting. The weirder one is, which I hope you will never encounter in practice, and I don't think you will, is this one, where you basically have this weird expression over here. You have like these nested template types and then some name lookups as part of the type defs that are inside. And if you run this program in C++3 mode, so if you compile and run in C++3 mode, it will return 100. If you compile and run it in C++11, it will return 0. So it's the same exact program. The compiler will likely warn you that the meaning changes, but I find it interesting how such a small change can completely alter the output of a program. I'm not going to spend much time on this. You can play around with it later, but basically it boils down to the fact that this double closing angle brace here is interpreted as a right shift in O3 and is interpreted as closing the other things in the C++11. So it's just to prove a point, but not a real interesting example here. But how about other ideas like attributes seem innocent as well, but there are some attributes specifically, compiler specific one, like the GCC provided attributes and things like that, that when misused can make your code ill-formed NDR. If you don't know what that means, it means that your program is completely broken and the compiler is not allowed to diagnose it. So you are compiling your program, it probably will run, probably will do the right thing most of the time, but it might break at the worst possible moment. And I'm talking about stuff like GNU Pure and GNU Cons and stuff like that. And this was also surprising for me because I was under the impression that attributes were just supposed to be, extra things that cannot change the program's semantics, but these can actually break your program. External template, this was one of the most disappointing discoveries for me. I was under the impression at the beginning that external template could improve compilation times if you use it properly, and you had template instantiations that were widely used throughout a code base, but testing it and looking at how it works showed that sometimes it makes things worse, even for commonly used types. So sometimes it can make compilation time longer or code size bigger, which is exactly what you don't want. We want the opposite from external templates, so that was kind of weird. Major singletons, those are amazing. You can just have your own function, have a static variable inside the function, and now it's guaranteed to be thread safe, initializable for multiple threads at the same time. So it's going to automatically prevent multiple threads from stepping over each other. But even that doesn't give you a foolproof singleton. There are issues with destruction order. So if you're something like a logger singleton and something that depends on the logger, you have to be really careful on how to on what the destruction order is, and you have no way of guaranteeing which one gets destroyed before the other. So those are some other pitfalls that we encounter. And even stuff like row string literals, which are great for embedding things in your code and making it look nicer. We use this in test drivers a lot when we're embedding JSON or stuff like that. Even encoding white space, when you have issues with, carriage returns on Windows versus Linux and things like that, what is the standard supposed to do? Is it supposed to encode it as it is, or is it supposed to convert it to a new line? There's a lot of gotchas in there that over the years researching these features again, I was really surprised to see. And I recall, in many meetings with John and other people, we discussed things and we're like, is it really that way? Why is it that way? And it's been kind of weird, but it's the C++ experience and it's been a very good learning one. So what I want to say is basically almost every feature has a dark side, even the most innocent ones. Most of the times you don't have to care, but when you're teaching and when you are, a large company and you have thousands of engineers working on 11 code or 14 code, someone is bound to get into the dark side and you want them to be prepared. And this brings us to the problem of modern C++, let's say at scale. What does it mean to be at scale? I've been teaching 11 and 14 Bloomberg for quite a long time now. And I devised a course from scratch that basically brought people up to speed with the new standards. And the hardest part for me is not doing the teaching. The hardest part for me is basically deciding what to teach and ensuring that what I'm teaching is going to result in the best possible outcome and not kind of promote bad practices or bring people to things that are harmful for the company and for their code bases. So what features should I prioritize? What features should I avoid teaching? And also I have to think about the diversity of people that are in my classroom and the impact of our style guide, which is quite important. And in terms of diversity, like when I've been teaching both at Bloomberg and outside, I've seen huge ranges of different people. the age range could be from 21 to 70 plus. Some people had a lot of prior C++ experience. Some people had just barely started using C++ for free. They were just new hires. Some people had a lot of development experience, maybe not necessarily C++, but they were used to other languages. Or some people were just, very young, came out of university with a very basic C++ understanding, and now they were getting bombarded with this like 11 and 14 stuff. Some people are naturally interested in modern C++. Some people are passionate about it. Some people like following the evolution of the language. They like to be up to speed themselves. So some of them were actually already up to speed. Well, some don't really care, and that's totally fine. Like for some people, it's just a job, right? And you want to enable them to do the job properly and effectively. But you also have to think that they might not be as excited for some features as you are, and you need to sell them in the right way and show the actual productivity benefits rather than, pointing out how bad it was before, because they just don't care. And some people work on libraries, some people work on application code, and there's a huge difference in interest there as well. Style guides is another thing that I want to briefly touch on. And I think that, I like my freedom when I work on my own projects, but when a company has thousands of engineers and you're not Google and you don't have, your special code governance tools that allow you to basically refactor everything magically and automatically and get code metrics easily, then a style guide is kind of essential, because you need to promote consistency and discoverability. If you don't have like an infrastructure that allows you to basically just look at your entire code base and do research on it, do queries on it and stuff like that, how are you going to ensure that you know how to find stuff? Are you going to ensure that people are being consistent? And you need a style guide. That's just the way people have been doing it in the past, and it's quite effective. But the thing about this slide that I want to point out is this question here. What is the input to a style guide? I think this is very important, right? Because many style guides are opinionated. Many style guides tell you what to do, what not to do, and the good ones also tell you why they decided to do that. But how did they get that? How did they get there in the first place? So one of the things that I guess we're trying to solve with the book is we are trying to be an input to style guide writers. We're trying to provide information which is factual and provide try to condense the experience that we've seen by teaching and using C++ at a company like Bloomberg and other reports of other companies and people that have been working with them in a large scale as well, into something that can be digested and can bring people to have a style guide which is not opinionated because I don't like that feature or I don't like that other feature, but because they've seen and noticed the experience that we had over the course of the years. And now we can talk a little bit about the idea of safety of a feature, which is something that we use in the book as well. Now, safety is a word that we chose explicitly to be a little bit provocative. Of course, every C++ feature is safe when used correctly. If you know what you're doing and if you're using it in the proper way, then it's going to be safe. But what is the likelihood that a feature is used correctly? Does the feature have any attractive nuisance? And what we mean by that is like, it kind of promotes you to do something which seems very attractive and natural, but is actually harmful. And some features do things like that. What are the advantages of using a feature compared to its risk? Very basic example, like if you use auto, you're going to get a lot of advantages by avoiding long type names, getting type inference and stuff like that. But there are risks for readability and things like that. This has been covered a lot of times, so I'm not going to spend time on that, but it's a good example. And then about teachability, for me, is important to know, is this feature worth teaching to a new hire? Is it going to do more harm than good than teach it? Is it going to confuse them? What about an experienced hire, somebody that has more years of experience? Are they going to make a good use of this feature? So this is what we're trying to capture with this notion of safety. So directly from our book, this is the definition we use for safety. We say that the degree of safety of a given feature is the relative likelihood that widespread use of that feature will have positive impact and no adverse effect on our software company's code base. So as you can already tell, it is not an exact science, it's a little bit of an art. It relies on teaching experience and usage experience. And in general, it's just a useful metric to decide what to teach and what to focus on as part of your company. Here's the the three categories that we identified as useful categories. Safe features are add considerable value. They are easy to use and hard to misuse. So we say that basically adopting these features in the entire company and teaching them to new hires is productive. It's not going to cause any harm and is actually going to help the code bases get better. Conditionally safe, they still add considerable value, so they're a really important feature, but they are prone to misuse. So you want to teach them, you want people to use them, but it requires in-depth training and additional care. Like you don't want them to be sprinkled everywhere. You want people to actually be very conscious about what they're doing with this. And then there is like this final category, which we say unsafe, but again, it doesn't mean they are inherently bad feature. It means that this feature only provide value only in the hands of an expert, and they can be prone to misuse. You wouldn't want to teach these as part of a general sales by 714 course. These require explicit training on their use cases and pitfalls. So my advice for this is basically teaching them as separate courses. Just to give you some examples now. The prime example of a safe feature for me is the override keyword. And this is because override, prevents bugs. It makes your code self-explanatory, and it really doesn't have any technical downside. If you've never seen it before, you should get accustomed to it. What it basically does, you can use it to mark any function that is overriding a virtual function in the base class, and the compiler will ensure that that is actually happening. So if somebody goes in the base class and changes the base class function, declaration, then the other class will actually stop compiling, telling you, hey, you need to keep them in sync, which is quite good. And still, even override, which is safe and we encourage to use it everywhere, there are still pitfalls. And the pitfall here is not technical, it's more like a people pitfall, which is what we care about when we're talking about experience. And it's about relying on override without enforcement. If you have a large code base and pretty much almost everywhere you use override, you get so used to it that if you see override, you are sure that something is overriding. And if you don't see it, you are sure that something is not overriding, then you might fall into problems, right? Sometimes you might actually override something, but forget to put the override keyword in there. So you do need static analysis. You need compiler flags that allow you to enforce that override is always there. And from the chat, I see Leven. Yes, thank you. There is a compiler flag in both. I think both GCC and Clang do this. But GCC, you have to be explicit and say W suggest override, and it will tell you, hey, you could have put override there, but it's not there. So you need to know these kind of things to make effective use of this feature, and sometimes it can trick you a bit. Conditionally safe, range-based for loops. They are the bread and butter of code bases. Every time you want to iterate over a container, most of the time you just want to iterate over every element. You don't really care about pointers or iterators or anything like that. But these have some issues. And, you're probably aware of this, but I've been aware of this issue for like 8 years. And this happened literally like last month. I'm working on an open source project, which is called Open Hexagon. It's a game that I've been releasing on Steam. And we had like this system where basically we allow people to obviously change their keyboard bindings for the game. And we had this idea of combos, which is basically a combination of keys. And we had like these function objects that give you back, some triggers to decide what to do with their actions and stuff like that. And basically we had this range-based for loop where I iterate over all the combo objects returned by this function over here, which was basically user provided to decide how to want to perform an action in the game. And my definition of trigger getter, which is what is returned by this first function call over here, you can see it down here. It just returns a vector of combo get combos by value. So do you think this code is okay, or do you see any issue with this code? Question for the audience. Okay. I see various answers. So this code was actually okay. There is nothing wrong with this code. And this code is okay because I'm returning the vector by value. And if I'm returning the vector by value, it is guaranteed to live long enough for the duration of the range-based for loop. because it's gonna use lifetime extension. Under the hood, range-based for loop takes a forwarding reference to whatever this expression returns. And if the expression returns a PR value, which in this case it does, which because I'm returning by value, this was completely fine. So it doesn't matter what I did with the loop. This was fine, was working just okay. And I know range-based for loop. I'm an expert. I've been using it for like 10 years now, right? But then what we did is we realized computing the vector combos can be expensive sometimes if the people have a lot of triggers and if we're displaying this every frame on the menu. So we decided to cache it. And inside trigger getter, we changed it so that we had a vector combo as a data member. So it was cached. So every time you change your binding, it was saved rather than computing it every single time. And then we had our signature of the function change to return it by a const reference rather than by value. We didn't touch the code before because it was just working fine. And we tested it and everything was working fine as well. So no problem at all. Until the replace system started getting bugged and we started having replays that just resulted in the player doing something completely different from what was recorded. So it was like a very weird bug, one of those that happens once in a while. And I had no idea where to look. I looked at the replace system for ages and then I was like, screw this, right? I booted up Linux, I went into an address sanitizer, and address sanitizer told me, hey, there's a bug in your range-based for loop. You are iterating over stale data because the data is going to be destroyed. So this is why you need to have awareness of these issues, because it was fine before. Then you do some refactoring, which looks very innocent. I'm just caching a data member, and some code in some different part of the project just goes and breaks. And if you don't know why, you would have to investigate, like I did with address sanitizer and stuff like that. It just takes time, and it's just frustrating. And the problem here, if you're not aware, is that when you return it by a const reference now, lifetime extension doesn't kick in anymore. And when lifetime extension doesn't kick in, it means that the result of the function get combos will be just thrown away immediately. It will just be destroyed before the first iteration. So you just lose that and you're going to iterate over data that's UB, and the whole program is going to be UB. So you don't know whether it's going to work or not. So range-based for loops are fantastic tools, but you need to be aware of their pitfalls. So you do need a little bit of additional training. That's what I'm trying to say. I'm not trying to say not use them, because that would be not productive, right? You actually want people to use them, but they need to know about this stuff. And it's not really things you will want to teach on the first C++11 course for new hires, right? You don't really want to teach them about PR values, lifetime extension, forwarding references, and all that stuff. But the truth is that range-based for loops rely on that. So you need to find a way to make that information, to convey that information to the students. This is why they're conditionally safe. They're good. They have very good use cases, but you need to be careful. And this categorization we have is not something that is set in stone. It might change over time. And fortunately, there are people that are working on making the range-based for loop safer as a feature. There is this paper, P2012, which is written by Yusudis, Zverevic, Mulonde, and O'Dwyer. And this is basically trying to fix this issue with the range-based for loop and changing the way the range-based for loop works in the language to avoid this lifetime extension pitfall. So, maybe when this gets approved, and maybe C++ 23, then the range-based for loops will be now a safe feature. So it's something that can change depending on how the language evolves. And finally, I want to show you an unsafe feature. And again, this unsafe, just imagine every time I say unsafe, it's in quotes, right? And this is decal type auto. And decal type auto has some very important use cases, especially if you're doing metaprogramming and library development. Yet I've seen it often misused without proper training and care. And this is my fault. I'm going to take responsibility. I'm going to tell you why. So here's an example, higher order functions. So higher order function, if you don't know, is just a function that takes another function as an argument or returns a function as its return value. And these are really useful when you're trying to write code that's, functional composition, and you're trying to compose your code from smaller pieces together, and this kind of like framework where you can do things like that. And, something basic like log and call is this template function. It takes some callable object F, then it logs that it's invoking it, and then it returns whatever F returns. So how do we ensure that we don't really change the semantics of the original function object f? Maybe it returns maybe it returns by value, maybe it returns by reference. We don't know, because f can be anything, right? So decal type auto as a return type is an effective way of saying, look, I don't care, whatever f returns, I'm just going to return the exact same thing. You still need to know that you have to forward here and make sure that your code is correct, but this is going to ensure that whatever f returns, log and code is going to return the same thing, which preserves references, constants, and whatever. So my mistake was that I used to teach decal type auto right after auto and decal type, and my train of thought in that approach was, let's provide a complete overview of the type inference, right? We're going to start with auto, we're going to then move on to the decal type, and then just combine them together and get decal type auto. And the results were that students were actually overusing decal type auto, and they were mostly confused by it rather than being helped by completing this like type inference section. And I remember some students thinking, look, if decal type auto does everything that auto does and more, why not use it all the time? Like, I've seen people just sprinkle it everywhere. Or if decal type auto is more flexible, why not use it when I'm not sure when to choose between auto and autoref? This was a little bit more, a logical question. Sometimes you don't really know whether something can be a reference or a non-reference. So people started using it as their variable type inference placeholders. And again, I take responsibility for this, and I do it differently today, and it's getting better results. But this shows you that if you're familiar with something, then you might not always see the perspective of your students. And sometimes something that is like more flexible is regarded as better, when it's actually probably the opposite. There is this talk by Kate Gregory, which I love. I don't remember the name of the talk, but she has a slide where she tells people, and placeback is very powerful. It can do everything that pushback does. And this is why you should prefer pushback when you can. And it seems counterintuitive, but it makes complete sense, right? Because when you want to solve a problem, you want to use the simplest tool that solves the problem. You want to use the most limited thing that solves the problem. If you use the most flexible tools everywhere, then you lose meaning. You lose semantic meaning of what you're trying to do. So the example with pushback and placeback, if you use pushback, people will know you've done that because you cannot do any better with placeback. If you use placeback, people will know you've done that because you get a benefit from using placeback. And this is the exact same principle with auto and decal type auto. You should only use decal type auto when it's the solution to your problem. And even if you could use it everywhere and get the same results, the truth is that you're going to confuse people and your code is going to be less readable. So this is why I think this is unsafe. In general, if you think about it, to really understand where decal type auto is appropriate, you need to have a solid grasp on type inference and value categories. You need to understand all of those things. You also need to be experienced with decal type and auto, being shown a few slides about them is not being experienced. You actually need to go into production code and use decal type and auto separately, and then you can figure out, oh, this is maybe where I would need decal type auto. And then also you need metaprogramming experience. Even knowing about Sphena is kind of a requirement, because if you use decal type auto as the return type of a function, then that function might stop being Sphena friendly. Sometimes you might actually want to copy paste the body of the function as part of the signature in a good old-fashioned decal type so that you retain that Sphena friendliness that you might need. And truth be told, I researched this a lot. I even opened a Stack Overflow question and set a bounty on it and whatever, but I couldn't find any valid use case for a decal type auto in variable position. So I'm happy to be proven wrong today. If you have a good use case for decal type auto as a placeholder of a variable and not a function, please let me know, but I couldn't find any. And the only real valid use cases I found are for return type placeholders. And those as well, you have to compare them against the alternative of using a train return type or a type trait based return type. So in the end, it's far from trivial. I was naive when I was thinking about, let's just teach it right after decal type and auto because it's just a continuation. But the implications of teaching that are wide and large. You need to be careful about that. Yeah, so some more examples. You can look at this slide. We deem attributes as safe, null pointer, static assert, digit separators are all safe things. conditionally safe, auto, context per, or by reference. And more unsafe things, we have the dreaded, carries, dependency, final, inline namespace, and some other things. Fortunately, I feel like if you look at this table here, which is the count of features that are safe, conditionally safe, and unsafe, I'm happy to say that most of the things that were added in 11 and 14 either are safe or conditionally safe, and only a few of them, like 7 features and 2 features in 14, are a little bit risky and they need more training. But the trend is that fortunately, most of the things that are being added in the language are on the safe side of things. And I didn't really do any, very deep research about 17 and 20 yet. 20, I don't want to talk about it, but 17, I also intuitively think that most of the things in 17 are quite safe. Okay, so what is the lesson that we get from this categorization? Why do we do this categorization? Well, for me as a teacher, and even if you are not a professional teacher and you just want to mentor people and you want to help your coworkers, I think these points apply as well. For me and for you, hopefully, what you should understand from this is that safe features should be taught early and quickly. Like most of them are quality of life improvements. They are hard to misuse. Trust your students, just tell them about it, let them use them, and probably nothing will go wrong. Conditionally safe features should be taught because they are useful, but you need to build on top of the safe knowledge. So you don't want to just, bombard people with things that have a lot of pitfalls and a lot of annoyances. You want them to slowly ease them into it, have some more time and examples to figure out how they work, have some examples that show how they can backfire in practice, want to scare them a little bit. And then I like to do this, have exercises that make the students question whether to use a feature or not. So kind of like a fill in the blanks, I might give them some sort of code and tell them, find places where this feature might be beneficial. And there are places that are like red herrings where they might put it and it might still work, but the code is either slower or less readable as a result. And I want them to actively think about what are the pros and cons of using the feature in any of these places. And for unsafe features, I would say don't teach them unless you have a self-contained, small course or reason to teach them. Like for me, of course, since I'm teaching at Bloomberg, something like inline namespaces, I know that they can have some very good use cases, but they're also very weird and you can get them wrong very easily. And they don't really scale as well as I thought they did. So I would have a small course prepared on, how do I version my library API and API with inline namespaces. I wouldn't teach it as part of a general C++ 7 and 14 course. And maybe for you, if you're mentoring somebody and they ask about this feature, you want to take your time and ensure that you fully understand what are the implications of it so that you can actually provide information that is driven by experience rather than just reading the feature on CP reference and understanding the syntax and the basics. So that's what I'm trying to say. Unsafe features require a lot of thought, both on the side of the teacher and the side of the student. Okay, so any questions so far before we look at one of the case studies? Oh, there is a good question. Why is final unsafe? So, John, do you want to take this one? What do you think?
Sure. This is largely my fault. I'll take responsibility for this. The reason that we have chosen to make final unsafe is not because it's a difficult feature to teach, and not because it does anything that you wouldn't expect it to do. In fact, override and final were presented in the same paper, and they're of comparable complexity. The thing is that override can do no harm, whereas final is a company-wide decision. And so if you're a company that has the ability to go in and quickly update a component, a reusable component, to be not final, then there's less harm done than if you're a company where the release cycle might take weeks or months, in which case going and finding whoever it is that made the thing final and telling them to make it unfinal so you can actually use it is a problem. Now, the reason, again, also is this is a very controversial thing. For people who have the view that what we want to do is we want to provide the least amount of work, and then when we need something, we'll add it. That's a company-wide decision. And it's not that it's wrong, it's just a different way of doing business. The other side of the coin is hierarchical reuse. And I'll make a plug for my talk, which is later today, which will explain hierarchical reuse. And after you've seen that talk, the very idea of making anything final would be counterindicated, except where you specifically want to ensure that a user-defined type isn't used in its full capacity, because later it might be used as a built-in type through a type def, and we have specific examples of that. And so there, if you didn't use final, it would be malpractice. So again, just because something's a Chapter 3 feature does not mean that it isn't useful and it isn't needed and it doesn't have fantastic uses. It means that it's not something you want a junior engineer to decide for themselves. I hope that answers the question.
Yeah, I think it's good. I want to just expand a bit on that. But I've had use cases where I've derived from something which is not polymorphic, and I just derive from the structural inheritance side of things, right? I want to just avoid some code repetition. It might not be the cleanest solution, but it might be just what I need in certain situations. And also there are things in the language that are a little bit quirky. For example, if you know about the empty base optimization issues, if I'm writing some sort of like tuple-like object and I'm writing some sort of like metaprogramming kind of utility that bundles things together, I might decide to use inheritance not as a tool to represent an is-a relationship, but as a tool to apply empty base optimization wherever possible. So now you're making my life harder if you have final types when implementing that thing. I can get around it, but in general, like I never felt like sprinkling final liberally is a positive thing, because you don't really know when people might want to inherit from your type, either to avoid code repetition or to do this kind of tricks like EBO and things like that. And in the context of a larger company, it's even worse if you end up needing to derive from something and then you have to talk to 5 different teams to have them update your code, and it takes a long time. So that can
I give an example actually, just to amplify what you just said? If you think about std vector, there are 2 things about std vector that I've talked about, one for years and years. Why wouldn't you want to make the destructor of std vector virtual? And the answer is you would impact everybody, because now everybody's footprint would go up by one pointer size, and that would be absolutely catastrophic. So no one in their right mind would ever do that. By the same token, if you're Bjorn Strustrup himself teaching in his course and you're trying to teach people how to write a checked vector, and you don't have C++ 20x contracts, the only thing you can do is to re-implement them yourselves with macros, or you can derive a checked vector from a vector and hide the bracket operator. And so that's what he did. And so what you'd be doing is telling the inventor of the language he can't use his own language to teach in his own school. So that's a little bit rude.
Yeah, I guess that's a good example. I wouldn't say it's the cleanest solution, but it's a pragmatic solution. And that's what matters in some cases. Like, you don't want the most elegant thing. You want something pragmatic that works. And sometimes final can be something that prevents it. Cool. So let's move on. I want to show you like this this case study on extended thread declaration. I think it's quite interesting. This was one of the features that I was a little bit unfamiliar with when we started doing the research, and I felt like I learned a lot about them and some use cases that I didn't know before. So first of all, what is this? What am I talking about? So prior to C++11, friend declarations always required something called an elaborated type specifier. And that is just the standard Ds for a syntactical element having this form where you have either class, struct, or union, and then an identifier. So it's kind of like when you do a forward, how do you call it? Like when you are declaring something without defining it, but you put friend before it, that's exactly the same syntax. A forward declaration, sorry, my mind was just escaping me. So example here, I have this struct s declaration over here, then I have this struct example, and I want to make s a friend of example. So what I can do in C++3 and also 11 is say friend class S semicolon, that's going to be okay. But at the same time, I can also do something like friend class non-existent, and that's also going to be okay. And this is going to be both a declaration of a class called non-existent, and also it's going to make it a friend, which is kind of weird. Is like the friend keyword is doing two different things. It's both declaring and it's also befriending, which sometimes can cause problems. And also, if you are, if you're looking at the slide, you can also see this is a struct, this is a class, there have been smashed there. It doesn't matter. The compiler will accept it. Some compilers would warn, but that doesn't really matter. Yeah, somebody just said that in the chat. Good catch. The restriction of this weird elaborated type specifier thing prevents other entities to be designated as friends, and sometimes that can be useful. And by other entities, I mean stuff, for example, like type aliases or template parameters. These are types, right? We should be able to befriend any type, but that wasn't possible before 11. So as an example, if I have some sort of like platform-dependent code, and I am switching between a Unix window manager and a Windows window manager by a type def, like this one over here, and then I have some sort of struct and I want to befriend the window manager, which I don't know what it is in advance, I would like to do something like this. I would like to say friend class window manager, but that doesn't work because window manager is not a class, it is a type def. Furthermore, if I have a template parameter T and I want to befriend it, I wouldn't be able to do that. I cannot say friend class T because this is declaring type called T, but there's already one in scope. So those are both going to be errors in C++03 and 11 as well. So, and also it can be even worse. Sometimes it can be very confusing. Sometimes you can have, your struct S outside, maybe in the global namespace. Then you have a class in another namespace, like this namespace NS. And as part of your class, you want to declare S as a friend. So you do something very simple. You just say friend struct S. But now instead of actually befriending the existing struct S that's outside in the global namespace, what you're doing with this line of code is actually declaring a brand new type, which is NS : S. It's part of the namespace and befriending it instead of referring to : S. It's weird. Like, this is not intuitive. It's not something you would expect. There are ways of getting around that, but it's just not a friendly feature. Let's put it this way. So in 11, they changed a little bit. They allow you to basically just extend this friend declaration, and you don't have to say class, union, or struct anymore. You can simply say the friend keyword and then provide anything which is a type, and it's going to work just fine. So as an example, I'm going to have my struct S again. I'm going to have my alias, S alias. In this case, I'm using a type def, doesn't really matter. I'm going to have my namespace, and then inside the namespace, I'm going to have this template, struct X4. And now I can do whatever I want. I can befriend T by simply say friend T, and it's going to befriend the template parameter. I can say friend S or friend S alias, and they are both going to find the same declaration over here outside, and they're going to befriend that class. I can say something like friend decal type of 0. It doesn't matter. Anything that is a type is allowed here, and decal type of 0 is just another way of saying int. And if I attempt to say something like friend C, where C when there is no C in scope, it is not going to magically declare one for me. It's just going to say, look, C doesn't really name a type, so it's going to be a compile time error. So for me, intuitively, this seems like, very good change. It makes the feature only befriend rather than declare and befriend, which makes it simpler and avoids some sort of issues.
Vittorio?
Yes.
I want to show my age. Before C++ was standardized back in the day, this is how it worked. And one day when I finally got the new compiler and tried it, I was working at Bear Stearns at the time, it stopped working and I was sad for like 20 years. And then all of a sudden it came back. I never knew it. So for anybody who's anywhere near my vintage, if you used to say friend foo instead of friend class foo and you were disappointed, it's back. And it's not unsafe at all. It's definitely the right thing to do.
Cool. However, we categorize this thing as unsafe. And why? So first of all, I would start by saying that if the book also covered C++03 features and we were covering friend, I would also put friend as unsafe. In general, friendship, I feel like can be useful sometimes in some very specific use cases, but in general, it just leads to bad design. And that's something that I've experienced myself. It's something that I've seen being reported in multiple places online and on papers and things like that. You know, when you have this kind of relationship and you're basically telling your class, look, I know you have these private fields, these public fields, the protected fields, but this class over here doesn't care and can do whatever it wants, then you know you are kind of like destroying a bit of the encapsulation that you have. There might be good reasons to do that, especially if the classes are very closely bound together. They're part of the same component and they are, you know, closely interlocked. They do two things that need to be done together. But as soon as you have friendship between things that are defined in different components or they have different, you know, different purposes, then it becomes really hard to reason about that code. And every time you want to test one of those things, you cannot really test it thoroughly unless you test the other thing as well. And this is what we call long distance friendship, is when you basically have friendship between things that are not in the same component, in the same physical component, and they might have different, you know, places where they live and different purposes and stuff like that. And extended friends declarations in one way make it easier for you to have this long distance friendship. Because if you think about it, if you can befriend a template parameter, or if you can befriend an alias, you really have no way of being sure where that template parameter comes from, where that alias comes from. The template parameter could be something in a completely different library. And now once you have this, you start having these relationships between things that two different people wrote, maybe two different people own, and they are friends together. It just causes coupling in the code, which can be harder to reason about. Yeah, so in general, you know, when a type X befriends a type Y, which lives in a separate component, and by component, I mean, you know, separate like header file and CPP file, it's its own thing, right? Then you can't really test X or Y independently anymore. They are closely interlocked. You have physical coupling between these two components, which can lead to, you know, compile time, compilation time increase, and also a code base that's a little bit more tangled together. And you can have cycles in physical design, which can be annoying for hierarchical reuse and making sure that your code is, you know, very simple hierarchy of types that where everything depends on something else that has been tested before. So I'm not a fan of friends, never been a fan of friends. I've used them a few times, but not that often. I understand their value, and this can seem like it makes it more enticing, so it can seem unsafe, right?
Can I just give a quick example? The one canonical use of friendship is when you have a container and its iterator. And this way, by making the iterator and the container appropriately friends, you allow the sphere of encapsulation to exist between those two, but not extend outward. So this implements what would be called the open-close principle, so that outward consumers can extend it using the iterator, but don't have to modify it. And I guess the idea of long-distance friends implies physical dependency cycles when it comes to testing. And the two most important physical design rules that I've encountered in my life are no cyclic physical dependencies across physical boundaries like .h.cpp pairs, and no long-distance friendships across .h.cpp pairs. And if you follow those two things, that's pretty much what modules have tried to enforce in C++ 20. So that's it.
Yeah, good point on modules. But, you know, even something that's unsafe, as I was saying before, can have some really good compelling use cases. Let's start with something really basic about in typos. And this is exactly what John was talking about, the container iterator example. You know, this might be a sensible place where you want to use friendship because they're very closely related together, so it doesn't really matter, and they might need to know about their internals. And, you know, if you use C++free friendship, you can add your struct container iterator. You can make it you could say friend class container, so you can make a typo here, and the compiler is not going to say anything. This is going to be just fine. It doesn't care about your typo because it's just declaring a brand new struct, a brand new class with that wrong name. But if you use something like friend with the new extended syntax, it is going to prevent you from making these typos. So a very minor thing, productivity boost. You know, you don't have to go and figure out why is my code compiling or why is my friendship not working. The compiler is just going to stop you immediately if you have a typo over here. There are other interesting use cases that we found. We talk about this in the book, like customization points using type aliases, something like the Windows Manager example I had before, the passkey idiom, which is kind of weird and interesting. But one of them which personally surprised me was CRTP. And it surprised me because I love metaprogramming and I've been doing CRTP a lot. And I didn't realize how extended friend declarations could actually be helpful in that way. And after talking to some people and doing some research, I did find that they work really well together. And this is something I want to show you. So CRTP, if you are not familiar with it, it's a pattern that stands for Curiously Recurring Template Pattern. Why is it called that way? Because it happens quite often that you have something like a base class, which is a template, and it takes some type named T, and then you have derived class, you derive from this base, and you pass derived as a template parameter for T itself. So the reason you want to do this is to inform base who derives from it. And base can have that information because it's a template, and you provide this derived type as part of your template as a template argument over here. Why is this useful? It's a very useful tool to basically do avoid code repetition and implement mix-ins. So mix-in, again, if you're not familiar with that, is basically a piece of functionality that you can inject inside of an existing class to avoid implementing it from scratch. For example, if you want to have, comparison operators, if you want to have a toString or something like that, instead of implementing yourself manually over and over again, you just write a mix-in, like with CRTP, and then you put it in, and using this technique here with inheritance, and now the mix-in will be able to figure out what the derived type is and do something with a derived type. And also in general, when you have some code repetition, CRTP can be useful to avoid code repetition and factor it out. So here's a basic use case. Let's say you are interested in tracking the number of active instances of some objects. Maybe you have a class A, and you want to track how many instances of A are active at any point in time. So you have the static integer called scount, which is your declaration. It's going to keep track of the number of instances. And then you, increment this counter on construction, copy construction, or move construction. And then you decrement this counter on destruction. Then you're going to define it in a CPP file, and it's going to work and just do its job, right? But now let's say other than A, you also have B and C and D, and you want to do the same tracking for all of these classes. You want to minimize this code repetition, especially when it involves having to write, static variable in the class setter, and then in the CPP file, you want to define it. It's cumbersome, it's annoying, it's a lot of repetition. So how do we factor it out in an effective way? CRTP comes into play here. You can have something like this mix-in called instance counter. It will take a type name T, which is going to be the class itself, so the derived class itself. Then we make this counter protected because we want to modify it from the class that's being tracked. And we provide a public count member function to get out the counter. And then in the header file, we don't have to do this CPP file because it's a template. We can provide a definition for the static variable over here that just returns provides storage for the static variable. Now, we haven't factored all of the code out. We still need to manually increment the counter, but we have dealt with all the static variable shenanigans in an isolated way. So now we can reuse this, and we can say something like, okay, I have my struct A, I use the instance counter, and it will increment on construction. I have my struct B, I use the instance counter, and it will increment on construction. So this works, code is completely refactored, and I don't have repetition anymore. But do you see any issue with this code on the screen? Yes, typo. And it's not a typo, it's an intentional typo. I am deriving instance counter of A here, which is correct, but I'm deriving instance counter of A here, which is incorrect. This should be B. However, the compiler is completely fine with it. This compiles, it runs, and at runtime, it will increment the wrong counter rather than the right one, which is unfortunate because I like it. It's clean. I don't have repetition anymore, but I just introduced a bug, a defect by refactoring. And I don't like that. It's just annoying. So how can we prevent this from happening? Is there any way we can be a little bit more clever and avoid this problem? There's also another problem, which is a bit, less likely to happen, but some client might derive from A or from B, and then they are free to do whatever they want with the counter because the counter is a protected data member. So even a class that's further down the hierarchy can simply say, look, I don't care, I'm just going to hijack the counter and do something weird with it. And, you know, there's this thing called Hiram's law, which is basically says if something is possible, if something is accessible as part of an interface, somebody eventually will use it. So we want to prevent that. We want to minimize the chance of you know, something being misused. And it turns out that extended friend declarations solve both issues at the same time in an elegant way. And that was really surprising to me because I would never expect to use them in this context. So rather than making the counter protected, we actually make it private. So scount will now be a private static data member of instance counter of the mix-in. And then what we do is we befriend T by using the extended friend declaration. This is one of the use cases befriending a template parameter. Now, compared to having it protected, this actually provides a lot of benefits. The first one is that, you know, if you make a typo, like you have a mismatch between the class and the CRTP template parameter, then you will not be able to access scount anymore. It is not a protected data member that you can access. It is specifically granted access only for the thing you specify here. So if the thing you specify here is incorrect, this will not compile, and it will prevent that runtime defect that we had before. This is great. It's a very good improvement compared to what we had before. And similarly, if there's some client that wants to be a little bit naughty and mess with your counter, they are not able to do it anymore because, you know, A has an instance counter of A and just provides access specifically to A and not other things up the hierarchy. So somebody up the hierarchy trying to mess with the counter will not be able to do that. So again, it's kind of an intuitive place where you would use extended friend declarations, at least it was for me, but it makes complete sense and it solves some real issues in real code. So I thought that was really interesting to show, and it's something that, you know, I discovered quite recently, even though 11 and 14 have been out for ages. So yeah, friends and extended friend declaration in general, simple limited use, and I think they promote bad design in general, unless you know exactly what you're doing. But they have some nice properties. For example, here you can avoid typos and mistakes. They have this great synergy with CRTP. But due to their niche nature, you know, these are things you have to use only specific contexts when you have things that are tightly coupled together and stuff like that. We categorize them as unsafe. You need significant training and experience to avoid misuse. And we don't want to teach new hires, hey, you have this keyword friend that allows you to basically break encapsulation, because every single time they are going to have a small flaw in their design, which could be solved by basically slightly redesigning their classes. Rather than doing that, they're just going to reach out for friend, and they're going to keep using that poor design and just, you know, plug patches into it to make it work. But that's not something that we want to do. It's not something scalable. Okay, so before the conclusion, there's a question, and, you know, feel free to ask other questions. A question by Gessner, I hope that's how you pronounce your name. The container iterator made me wonder how friend works. I told the iterator we need private information of the container, and since the container would have to create friendship with the iterator. But the slide was the opposite. Yeah, you're not wrong. The slide is just slideware, so maybe it was a bit misleading. Depending on your use case, when you say friend T, it means that T has access to the internals of the class that the friend has been put in, right? So if you want the container to have access to the container iterator, you would do what we've done on the slides. If you want the opposite, if you want the iterator to have access to the container, you would have to say friend container iterator inside a container class. So maybe that was just slideware, you know, mistake, but your understanding of friend is not wrong. It's just that maybe the slide was backwards, let's put it this way.
I want to make just a suggestion. If you have something that's protected, you're saying that anybody can derive from the thing and then use the internal information that's protected. And this is sort of like the generic version of protected, saying that anything that's a parameter type can have access to my internals. And what makes this work the way it does is the person designing the system deliberately made it intentionally so that it would work that way because it's a closed framework. So it's the curiously occurring template pattern framework that makes this work at all. Otherwise, it's just kind of bizarre. Does that make sense? Think of it as a protected in a generic sense.
Yeah, or more targeted version of protected, right? You don't want to have it propagate. You know exactly what that should be, right? If you just use protected, then things of the hierarchy can also use it.
Okay.
Okay, so we're almost done. In general, like I learned a lot of things, and I hope I transferred some of that knowledge today and order more of the knowledge with the book if you're interested in reading it in the future. But 11 and 14 at scale for me are still an open research area. It's kind of weird to say it's been 10 years since 11, but 11 was such a huge, departure from what C++ was originally that it's still unclear whether, something should be adopted very aggressively, something should be adopted more slowly. The human cost of a feature is not easy to quantify, and also depends on a lot of factors, right? If you have a hobby project and there's like 5 people working on it, then you can, afford being a little bit more experimental. If it's a huge company, 4,000 employees, 5,000 employees, and you have mission critical software, then you have to be a little bit more careful. Categorizing features by safety helped me a lot, devising learning paths. And I think that, especially in a large company, but even if you're just mentoring a single person, you want to teach things that are helpful for both productivity and stability, and you want to minimize the risk of teaching them something that might backfire, right? So having that sort of like categorization is useful. And then all features, no exceptions, all of them have good use cases and some nasty pitfalls. Very weird things like extended friend decorations can surprise you. They can be very useful where you least expect it, like CRTP. But even things that are super safe, like override, can sometimes trick developers into a false sense of security when they, rely on it without actually having static analysis. And the only way you can deal with that is by knowing this thing. So again, cliche, but knowledge is power. So yeah, about the book, if you're interested in it, so it will be out in Q2 2021. We have this domain purchase. So far, it just redirects to my homepage because I was lazy, but eventually we're gonna redirect to the book homepage. And it's called Embracing Modern C++ Safely. It's been co-authored by John, me, and also Slava and Alistair. These have been super, this team has been great, and it's been great working with them. And it's been a lot of knowledge sharing and understanding of 1114 that helped everybody grow. There has been also many others contributing to it, reviewing and helping out, people from the ISO committee and people that have actually, developed the features themselves in the first place or brought the proposals. So I think this has been a huge project for me, something that I'm really passionate about, and I hope is going to help you out as well when it's out. If you're interested to know updates about the book when it's released, you can follow me on Twitter. I will definitely tweet about it when it's out. And that's pretty much it. But, we have a few minutes left, so we have questions. And also I have a slide here at the end that shows the feature we cover in the book and the categorization. So if you have any questions about why we put something in one category and not the other, then this is a good time to ask. And I think we can take some questions for about 15 minutes. So question from Lucian. The categorization of safe, mostly safe, unsafe seems to be more appropriate for beginners. Doesn't this affect the work of the more proficient expert programmers? How do you deal with this? This is a good question. I think to be honest, it is very useful for beginners, probably most useful for beginners. But even myself, as somebody that I consider myself, quite proficient, I found it useful to have this kind of like mental map and try to understand what are the things I should be more careful about. I've had my phase of using auto everywhere. I've had my phase of using no except everywhere. I've had my, weird intuition that told me, hey, extended template is going to make my compilation times faster. And I guess all of this stuff was kind of like coming from just assuming these things were always safe, assuming these things were well thought out and, worked in every situation. So I would say even like, at least for me, it's very subjective, right? But for me, even as somebody that's experienced, knowing that something is conditionally safe rather than unsafe helps me, just step back a bit and see, hey, am I doing the right thing here? What things should I be aware about? And, especially people that have experience, myself included, sometimes we fall into the trap of thinking, yeah, I've used this thing for like 5 years. I know everything about it, right? So having that kind of like belief being a bit contested by somebody telling you, hey, this thing is not safe, can be something that opens your eyes a bit and makes you a little bit more careful with that. And yeah, Felix has a great answer to this. Who is really an expert programmer in C++? Nobody is, right? Not even the people on the Accu committee, not even Bjarne himself. Like it's such a huge and complicated language that there's no way you can be aware of everything at all time. Daniel, do you think private versus protected has the same problems as final versus override? Would that make private unsafe? That's a very interesting question. I would have to think about it. It's not something I can answer right now. I'd be happy to have a chat later. It's an interesting parallel. I never thought about it. Intuitively, I would probably say I don't think so, but it's something that we could discuss about. I think it's an interesting idea.
Is the question more about private or more about protected? In other words, are we questioning the use of protected? Because there's a long story in the evolution of C++ where Bjarne talks about how protected came to be, and it's very funny because he was convinced by somebody down the hall that protected was absolutely needed, and they gave really good arguments. And so finally he put it into place. A couple of years later, he went back to the guy and said, so how's it working for you? He said, it's terrible. We had all kinds of bugs. We had to rip it out. And his advice was beware of compelling arguments. So protected is not something that we use that I use in my designs generally. And I would consider protected to be highly unsafe. And yet there are times when protected is exactly the right thing. So if the question was, is protected unsafe? Absolutely.
Yeah, I guess that's a good point. Like you said, private versus protected, final versus override. I guess it's the other way around. It's more like, if you want to put a parallel, I would say private is like override and protected is like final. That's the way I would put them together. But it's a very good parallel. I like that.
I would say that protected is like an extended friend in that sense.
Yeah. So follow-up question, what's your default, private or protected? Definitely private. Protected, as John says, is something that you need to justify using. You want to encapsulate things as much as possible, right? You want to avoid exposing implementation data as much as possible. And protected is a controlled way of doing that, which might have you might have a good reason to do it, but it's not something you want to do all the time. So I think that private should definitely be your default there.
From Hiram's law perspective, before I ever knew what it was, I've been saying this for 30 years, protected is 90% of public.
Yeah, I like that, yeah. Okay, so question from Matthias. Why is Enum class conditionally safe only? Shouldn't it be preferable over Enums in all cases where Enum class can be used? So this is something that, when we researched and when we discussed, we had very conflicting opinions on this. There's people that really like the type safety that Enum classes provide, but there's also some places where, after arguing a bit, I've also been convinced that classical Enums can be sometimes better. One of the examples of that is very simply, if you have something that you are using an Enum to represent some sort of like bit flags or some sort of thing that's going to be used mostly as an integer, and you blindly say, okay, I'm going to use Enum class just for the scoping and for the type safety nature of it. Of course, you're going to get those benefits, but it's going to be painful to work with the type as an integer. You're going to have to cast everywhere. And until recently, I think it was proposed for C++20 or maybe 23, we didn't have an std2 underlying. So to get the actual underlying type of the Enum, you would have to cast it with a type trait. It gets a bit cumbersome. You can basically also, create operator overloads for Enum classes. So if you find yourself using an Enum class as an arithmetic type a lot, you could also write out all the possible operator overloads. But again, that seems a little bit backwards. So for example, one of the places where you could use old-fashioned enum is in one of these cases where you have like the need for a bit flag, something like that. And you can also get the scoping. All you have to do is basically wrap the old-fashioned enum into its own struct or class or whatever. So you get the best of both worlds. You get the scoping and you get the integer-like behavior. There's other issues that might arise with Enum class. John, do you want to elaborate a bit on that?
Yeah, I think you covered it very well. See, it's the right tool for the right purpose. Namespaces are great until they aren't. Sometimes you want to put a static method in a struct to avoid ADL. If what you're trying to do is get ADL, then use a namespace. If what you want to get rid of is ADL, don't use a namespace. So if what you want to have is type safety and an enumeration where the value of the enumeration is absolutely out of scope for the design, use an enum class. Don't even think about it. If what you're trying to do depends on the value of the integer, don't use an enum class. Don't even think about it. Use a nested classic enum. If you're inside a function and you're trying to define return codes, don't use an enum class because you just want to access those values as constants. The enumeration provides the notion of having different things, but where their values are relevant. And an enum class goes exactly the opposite direction and protects you from making the mistake of relying on the values. So if you look at the book, it will explain very, very clearly when to use what and why. And it's not telling you you can't do it. It's just showing you why you'd want to. So that's the beauty of this book. It answers those questions.
I guess one thing I want to add is Enum class is one of the examples for me where it does a little bit too much. Like the scoping is nice, the type safety is nice, and the implicit conversions are, the disallowed implicit conversions are nice, but I don't have a way to choose between, right? They're all bundled together. So sometimes I might want the scoping and the type safety, but I still want implicit conversions. Or sometimes I don't care about the scoping and I want implicit conversion. But since it's bundled all together, sometimes you have to, be careful with it and decide, is this the right tool for the job? In general, I really like Enum class. I like Enum class way more than John. So, you can see my perspective. But I agree that there are some use cases where using a classical enum and wrapping it to get a type safety is better than using an enum class in terms of like developer productivity, amount of code that you have to write, and simplicity. So that's just
there's one other interesting twist to this. Because enum class and enumerators with an underlying type specified can be declared locally without the enumerators, you can create what's called an attractive nuisance, because someone might want to avoid the compile time coupling on the enumerators. And unless you have a forward declaration in your component that defines the enumerator, someone outside might think to just declare it as they might just declare an int. They might just say, here's an enum, and they never care about the enumerators. The problem with that is if somebody changes the underlying type in the library, that local declaration will become an undiagnosed bug in your code. It'll be ill-formed NDR. And by the way, NDR is no diagnostic required, which means if you had end-to-end linkage, end-to-end checking, it's possible for a compiler to tell you that it's ill-formed, but it's just not generally possible with separate translation units. So in this particular case, you get a buggy program that at runtime would just do weird things. And so, as I said, this enum class or even a regular enum with a specified underlying type in a library really does require a forwarding header so that you don't get people making really bad mistakes. This is explained in the book.
So let's see, I missed the order, but I think Andrew had a question. Yeah. So Andrew asked, I am disappointed to hear that the survey revealed many cases where a company couldn't use 11 and 14. What do you think the main reasons are? And also follow-up question from Barry, is there anything we can do as mentors, trainers to mitigate this? So I'm gonna answer Andrew first. So before answering, I wanna say the sample size for the surveys that you've seen, is significant, but not that big. We are like 3,000, 2,000, 1,000 developers. So it is it is showing what's happening in that part of the C++ community, which is active online and is willing to take surveys, which, you know, is a good chunk, but is not the actual representative of the entire community. However, I would like to say, in my experience, and by talking to people at conferences, by teaching my students, and by talking to my coworkers that have been in previous companies, and so on, I think that the actual truth is that even worse than the surveys. And it's quite sad to say, but 11 is still a luxury in a lot of places. And I've heard many different reasons why that is. One of the reasons I've heard frequently is, again, legacy architecture and build systems. And not just where you are basically unable to upgrade, but some companies just don't care about upgrading. They have their own, you know, setup. It works, it makes money. So they don't really have a justification to go and change what is working, upgrade all the tool chains and stuff like that. So it might be either a technical issue where you cannot upgrade, or it might be a people issue where you basically say, look, it's working fine. I don't really care about new stuff. This is making me money. I don't want to upgrade, which of course is going to be a negative impact on your employees. But maybe you as a manager or as somebody who has a lot of experience with something and doesn't really see the benefit of new things, don't really care about that. So these are two of the reasons I've heard. There's also a lot of skepticism with modern C++, especially, for example, in the game dev community. So I'm a hobbyist game developer, and one of my favorite pastimes is arguing with people on Twitter, because that's what every engineer does, right? And I've had a lot of like interesting arguments with people from the game dev industry where they basically kind of like reject this idea of modern C++. And most of them have really good points, you know? They say that some of the features that were added can lead to longer compilation times. They can lead to slower runtime. You know, there's minor things, right? But if you start, you know, if you're not familiar with lambdas and you start using std function, thinking that std function is something that is a cheap way to hold or store a lambda, and you use that in a tight loop, then it will, you know, slow down your program. So there is this very, you know, heavy skepticism and kind of like disdain of modern C++, because people have been burned by it and they have seen benchmarks and things that show how some of the tools can make things a little bit slower. And they think that the whole thing is garbage and the whole thing should be avoided. Well, in truth, what they need is kind of like something like what me and John and the other authors are providing. It's like they need to see, this is all that's available. What is going to help me and what is not going to help me? And for game development, you know, things that are in the chapter 1 and safe features, they are great, like decal type, null pointer, override, static assert. All of these things do have no impact on runtime or compilation time and can make your code cleaner and nicer. And I'm one of the people that strongly believes that game code shouldn't be throwaway code. It should be clean. It should be maintainable. On the other hand, you know, if you start, for example, using no except, which is an unsafe feature, all over the place in your code, you might be surprised because sometimes no except makes your code slower rather than faster. Sometimes the compiler has to inject you know, barriers around your, I'm not talking about multi-threading barriers. It has to inject some instructions around your function mark no except if it's called from a no except function, so that it knows when to call terminate, and that can actually make it slower at runtime. So these are also some reasons why, especially the game dev community, is a bit skeptical of modern C++. But I strongly believe that rather than rejecting it and saying, look, I'm not going to use this ever, instead doing research and figuring out what is beneficial for a code base like in a game, what is beneficial in a code base like for a, you know, network application or something like that, is way more productive and beneficial in the long run rather than just saying, no, I'm not going to use any of this. Barry, also, you had a very good follow-up question. What can we do as mentors training to mitigate this? So what I've done personally is, like, when I was joining Bloomberg, I was really happy to be in a place that was pioneering the evolution of C++, but I noticed a hole in the training. Like, I noticed that the training was still a bit stuck on C++ 3. There were some things here and there about 11 and 14, but there was no like, you know, there was no full-fledged course that brought people up to speed. So I just talked to my manager and was like, I'm really passionate about this, and I think this is going to help the company a lot. Let me have a go at it. Let me try to teach people modern C++ and show them why it's good. So I started with something basic, like a few small sessions, like 1 hour sessions as part of my training class. You know, I was being trained, but I also was training at the same time, which was quite funny. But people really enjoyed that, and they were interested in knowing more. So I kind of like started writing a 3-day course and workshops and things like that. And I've had really good feedback about it. And I think in general, anybody can do a little bit of teaching, a little bit of mentoring. And if you want to promote the good things about Multi-C++ 11 and 14, I think that focusing mostly on the safe features with some sprinkle conditionally safe features can help you show people, hey, this is what you're missing out on. All of these things are really safe to use. They are, going to improve your quality of your code. They're going to improve the quality of your life. They're going to make you more productive. So you need to sell it to them in such a way that they see what is the value for me as a developer. And remember, something I said before is not everybody's passionate about C++, and that's fine. Like for some people, it's just a job, right? And you also want to target those people. You want to show them what is in for you as an employee. How does this make your life easier and your product more high quality, without focusing, on the passion and the evolution of C++. Some people just don't care, and that's fine. And I think that's another perspective where I think trainers and mentors could do a better job, provide value, and show things that are safe and should be used widespread quickly and early. And I think that's something that I've adopted in my mindset, and is paying off for when I teach people these kind of things. Okay. I think we're out of time. Felix, last question. Why do you categorize default member initialize are conditionally safe feature? I'm going to be super brief about it because I have no time. But the short answer is there are some cases where in certain scenarios, if you have certain build systems or certain deployment schemes where relinking is way faster in terms of like people's time compared to recompiling, and you have some sort of issues with some sort of data member that was initialized in the wrong way, maybe some parameter that makes your code, be too fast, be too slow, or grow memory too quickly. Then, if something if a data member is initialized as part of a constructor in a CP file, you can change that parameter and then just relink rather than recompiling. If something is defined as part of the header, then now you have this coupling between the definition of the data member and its declaration. So if you want to change what the default value is, you also need to recompile everything that depends on it. And again, it's not a huge deal depending on how your build system and deployment system is, but in some cases it can matter. And even just recompilation times can be annoying depending on how your company works. So this is one of the pitfalls we encountered.
I want to add just one sentence here real quick. It's not so much compile time as it's compile time coupling. And so the concept of insulation allows you to make changes to the implementation without forcing clients to recompile. And again, it could be that the people who are clients are an intermediate layer who then in turn need to release to another layer. And in a large company, that can be a real problem. And it has been for me over the years. So it's an important concept to know at scale. It's completely unimportant for small projects. And that's it. We're out of time.
Yeah. So thank you, everybody. I think the questions that you asked and the observation were really good. And, especially some of the parallels that I didn't think about. And I think the discussion was really interesting. So thank you so much for coming and for participating. Hope you have a really great rest of the conference. And stay tuned for the book. And also feel free to reach out on any of, my emails, Twitter, whatever. Happy to chat later. Just ask me whatever you want. I'm really happy to chat with you.
And my talk's at 4.
Cool. Thank you, everybody. Bye-bye.